Now, today we are going to start a new topic and a very interesting topic, that is the rearrangement reaction. Rearrangement reaction. So this topic, you have seen that the depending upon bond breaking and bond forming, the chemical reactions are classified into four types. One, that is the substitution reaction. Second is the addition reaction. Third is the elimination reaction, and fourth is the rearrangement reaction. So these are the four reactions. If you see any one, if you see any reaction, you will see out of that it is one. Either it will be also oxidation or reduction reaction. So you should know this four reaction plus one, oxidation and reduction reaction. Then you can solve any question in the organic chemistry. So here we'll see what is meant by a rearrangement reaction. So there is arrangement, right? There is arrangement in a molecule, and when you rearrange it, so it is a rearrangement reaction. So in organic compound, so what you observe that there is either carbon skeleton, or it may be also have carbon or oxygen skeleton. Sometimes it may also have carbon nitrogen skeleton. So there's a bond between CO or Cn. So here, when there is a reshuffling of the skeleton in an organic molecule takes place, is called as a rearrangement reaction. So what is the rearrangement reaction? There is a rearrangement of the skeleton in a molecule is called as a rearrangement reaction. Reshuffling or a rearrangement of the skeleton is called as a rearrangement reaction. So here we have to learn number of name reaction that you have learned already in the previous year also. One simple reaction that you have to learn, that you have learned already, that is the Pinacol Pinacolone Rearrangement reaction. Pinacol Pinacolone rearrangement reaction. Pinacol Pinacolone rearrangement reaction. So in Pinacol Pinacolone rearrangement reaction, the starting compound is a pinacol. It has such type of structure. You are having carbon single bond, and on this carbon single bond there is OH. So here at 1 and 2 position there is OH. So it is a 1,2 diol. It is a 1,2 diol. It is also called as a pinacol. OL means alcohol. So it is alcohol. Pinacol, it is a alcohol. So it is a 1,2 diol or pinacol. And the valency can be satisfied by the R group, alkyl group. Maybe same, maybe different. So for this your in general, so I will take all R alkyl group. So here is R, here is also R, here is also R and R. All R may be same, may be different. The reaction takes place in the presence of, that is the acid H plus, in the presence of acid H plus. So you know here on oxygen you are having two lone pair, one lone pair and two lone pair. You can take any OH, either first OH on the carbon number 1 or second OH on the carbon number 2. So here it undergo protonation. So the sigma bond, the lone pair on this oxygen is given to the hydrogen, and it undergo protonation, and there is the formation of corresponding protonated system. So here is your R, here is your R, here is the carbon, here is also R, here is OH, which have two lone pair, 1 and this 2. Here is the carbon, here is also R, and one of the lone pair is involved into the formation of bond with the H plus. As oxygen gives a lone pair, So the oxygen carries a positive charge. So the oxygen carries that is the positive charge. So this O carries a positive charge, right? Now you have to neutralize this positive charge. So what happens? The sigma bond on this carbon and oxygen, it will open on this oxygen. Why? Because oxygen is having the positive charge. So I will write this positive charge again more nearer to the oxygen. So instead of writing there, what I will do, I will write this positive on this side, means the oxygen carries positive charge. Okay, as sigma bond open here, there is a neutralization of the positive charge. The reaction takes place in the presence of acid, in the presence of acid as H plus. So this water will be removed as a hydronium ion, S3O positive hydronium ion, right? And this carbon becomes positive. So you are getting here R, here is a C, here is also R, here is OH, and here is the carbon, here is also R, here is also R, and carbon becomes positive, right? There is a formation of a carbocation. So in this case, there is a formation of carbocation, and this carbocation is further stabilized by the resonance. So here is a H, right? I will write this H, write this one. Here is the H, right? Here is the H, and this is having a two lone pair, one lone pair and two lone pair. So what happens in this case? There is the formation of carbocation. And what is the nature of carbocation? Nature of carbocation is the tertiary. Why? Because carbon having the positive charge is directly attached to 1, 2, 3 carbon. So it is a tertiary carbocation. But this tertiary carbocation further also undergo a resonance. How? The R along with electron pair. So I write this circle R along with electron pairs, means there is a R negative, R along with electron pair. It will attack on this carbon. It will attack on this carbon. So as a result, this carbon carries a positive charge. Why? Because this sigma bond open on this R. You have to open this sigma bond on the R. R becomes negative. This R negative will attack on this R positive. R positive. So this carbon becomes positive. So what happens in this case? The lone pair on the oxygen, they are involved into delocalization. So there is a formation of a corresponding next resonating structure. So what you are getting? You are getting here R, here is a C, here is a double bond, here is double bond O, here is a H. As one of the lone pair is given, so oxygen carries positive charge. Here is the carbon, already there is a R, there is a R, and this R, which was on the carbon having the OH group, it will attack here. So this R get a migration. So it is called as a 1 to R minus shift. R minus shift. Why? Because the R is at 1 and 2 position. So we can write either here 1 and 2. So it is a 1 to methyl shift or 1 to R shift. So this is a rearrangement step. So this reaction, this step is important. It is called as a rearrangement step. And further, the oxygen having the positive charge. So this sigma bond again open on this oxygen. There is a neutralization of the positive charge. So in the reaction, we have used, that is the acid. So you have to remove H plus catalyst, H plus acid, and you are getting corresponding compound, that is R, C, here is a double bond O, here is a C, here is R already, here is R already, and this R is have migrated, means there is a reshuffling of the carbon skeleton takes place. So in this way, there is a rearrangement reaction takes place. So it is called as a pinacolone. It is called as a pinacolone. ONA means ketone. So as it contains functional group CO, it is called as a pinacolone. So it is a pinacol pinacolone rearrangement reaction. Pinacol pinacolone rearrangement reaction. So starting compound is a pinacol, and you are getting a pinacolone in the presence of acid. So it is a conversion of pinacol into pinacolone. Pinacol into pinacolone. So this general reaction in which there is a reshuffling of the carbon skeleton takes place. So it is called as a pinacol pinacolone rearrangement reaction. So here we have seen the one rearrangement reaction. In this topic, you have to learn the number of rearrangement reaction. So you have to remember the starting compound. Starting compound is the pinacol, and the product is the pinacolone. And what is reagent? Reagent is the acid. Reagent is the acid. And which step is a rearrangement step? Which step is a rearrangement step? Where reshuffling takes place, it undergo a rearrangement. Now, why it undergo rearrangement? Because here you will see that in this step there is a formation of carbocation. Why it undergo migration? Because as soon as there is the formation of carbocation, the lone pair on the oxygen, they are involved into delocalization. The lone pair on the oxygen, they are involved into delocalization, means it further undergo stabilization. That's why such type of R shift is possible. Such type of rearrangement is possible. So this step is called as a slow step. It is called as a rearrangement step. So in pinacol pinacolone rearrangement reaction, the starting compound is pinacol and the product is a pinacolone. So conversion of a 1,2-diol into ketone is a rearrangement reaction. Example, just you replace all R by same methyl group or pH group, you will get the next example. So here there is a general representation. Now I will write one example. Just I will replace R by methyl. You have to replace R by phenyl, and you have to write down the same example. So let us see the example of this pinacol pinacolone rearrangement reaction. So what is this rearrangement? The starting compound is pinacol, where there is a carbon-carbon single bond, and here there is OH, also there is OH, and I told you that all are they are replaced by the methyl CH3. Here is also CH3, here is also CH3, and here is also CH3. It is your pinacol. It is called as a pinacol. OL means alcohol. You have to convert the pinacol into pinacolone just in the presence of acid. So here, what happened? In the presence of acid, the one of the R will be shifted from 2 to 1, or can also write 1 and 2. And here you are getting corresponding compound CH3. Here is the double bond O. Here is the carbon CH3. Here is the CH3, and this also undergo migration CH3. So here we have migrated from this carbon. Okay, so just I will write this CH3 like this one. So it is your CH3. It is your CH3. You can write any R group. Even you can write the phenyl nucleus. Now let us see what is the mechanism of the reaction. Mechanism is also very simple. The reaction takes place in the presence of acid. The oxygen is having 2 lone pair. Either you can take the OH on the carbon number 1 or the OH on the carbon number 2. It undergo protonation. It undergo protonation in the presence of acid. You are getting such type of a protonated compound. Here is your CH3. Here is your OH. You are having 2 lone pair, right? And here is the carbon. Here is the CH3. Here is the CH3, and here is the O. Here is the H. You are having 1 lone pair, and one of the lone pair is involved in the formation of bond with the that is the H. I result, the oxygen carries positive charge. As the oxygen gives lone pair, that's why oxygen carries a positive charge. Further, you have to neutralize this positive. So this sigma bond will open on this carbon. There is a removal of water in the presence of acid, H plus. So there is a removal of water, carbon becomes positive. So you can write corresponding carbocation, and then you can write corresponding the next reaction. So here is the CH3, here is the carbon, here is the CH3, here is the O, here is the H, lone pair, and here is the carbon CH3, also CH3, and it becomes the carbocation, C positive, carbocation C positive. Now this carbocation further undergo rearrangement, 1,2-methyl shift. So I will write this bond, right? So here is your CH3, here is your CH3, right? So the methyl group along with electron pair, I will write the tail of the arrow here, and it attack on this carbon, right? The tail of the arrow here, and so just I will write one more time. We are having this CH3, right? You are having this CH3. Now this CH3 will attack on this carbon along with electron pair. So it is a 1,2-methyl shift, 1,2-CH3 shift. As soon as this carbon becomes positive, the lone pair on this will shift on this sigma bond. There is a formation of double bond, and oxygen becomes positive. So this step takes place simultaneously, and you are getting CH3. Here is the carbon, here is the double bond O, here is the H, oxygen having the positive charge, remaining part as it is. So CH3, here is also CH3, and this is your, that is CH3, which undergo shifting, right? Now further it undergo, that is the dehydration. So this sigma bond open on this oxygen. Why? Because you have to neutralize this positive, and when it undergo removal of a proton, so you are having such type of a pinacolone, CH3C double bond O. Here is the carbon, here is a CH3, here is a CH3, and here is a CH3. It is called as a pinacolone. So this is a very simple reaction called as a Pinacol Pinacolone Rearrangement reaction. The starting compound is pinacol, and the product is your pinacolone. So one of the methyl from the carbon number 2, it gets shift on the carbon number 1, or it is called as a 1,2-methyl shift, right? So in this way, I have taken also an example. Now you can take yourself, instead of R, you have put methyl. You can put the phenyl. When all R are same, then on the carbon number 2, as the both are methyl and methyl, you can shift on the carbon number 1. So as both are same, you can shift anyone, you get the same. But if the R, they are different, means one is methyl and other is a phenyl, then a question arises, what to shift, either methyl or phenyl. So it is called as a migratory aptitude, means which are undergo migration, which are undergo shifting. So it is called as a migratory aptitude. So in this way, you have seen the Pinacol Pinacolone Rearrangement reaction. So we have seen one, that is the general representation. Second, we have taken its example. So in this one, if in doubt, you may ask. यदि इसके अंदर कुछ आपको डाउट है, then you can ask. Okay, so here we have to also learn one. We'll take one more example of this pinnacle. Look here. While studying, what you do when you learn any concept, firstly find out that concept. What is the concept? Starting compound and then a product. What is a reagent? You have to remember the starting compound and then you have to also find out what is the corresponding product and what reagent. Sometimes you can take one reagent, sometimes you can take also more reagent. So you have to remember the list of reagents. Okay, after that one you have to remember the examples in this reaction, or you can take any example in any reaction and you have to write down its mechanism. First, let's see general mechanism and then you have to apply on the examples. So if you know one generation, then you can apply on any reaction and you can write number of examples. Collect examples from your textbook, collect examples from your question paper and try to write their answers according to the mark. So you can write answers of any question. Okay, so only one point you have to also write when both are they are different. Okay, each example, each rearrangement they may ask for 3 mark. Write down short notes on so and so rearrangement reaction. So here they may ask, write down short notes on Pinacol Pinacolone Rearrangement reaction. What is a rearrangement reaction? The reshuffling of the carbon skeleton in a molecule is called as a rearrangement reaction. Example, Pinacol Pinacolone Rearrangement reaction. Okay, so here we have started the topic rearrangement and we'll take examples. Last time we have taken one guest lecture, the molecular rearrangement through the solve problem. Molecular rearrangement through the solve problem. When you learn that concept in detail, if you know every concept, later on you have to solve that type of the question. Okay, so in this way we have to learn study of organic chemistry, right? So I think here we'll stop and in the next lecture we'll take that one more example and then we'll take the number of other rearrangement reaction. Okay, so thanks to all and we'll take new concept in the next lecture. Thanks to all and you can leave the meeting. Thank you.
Thank you, sir.
Thanks to all. Thank you.
Thank you, sir.
Thanks to all.